In this video, we're going to look at a transformation example problem, and we're going to start with the function m of x is equal to negative the absolute value of 4x minus 8 plus 1. And what we're going to do is we're going to start with the base function, which in this case is f of x is equal to the absolute value of x, and then we're going to make each change, each shift, or each shrink or reflection until we get to m of x. So here, the first thing that I'm going to do is rewrite m of x as negative the absolute value of 4 times x minus 2 plus 1. And now let's look at the picture of the base function f of x is equal to the absolute value of x. And you can see that it's a v-shaped function. It comes to a point at 0, 0, and I've labeled two other points, negative 5, 5 and 5, 5, and we're going to keep track of these points through each change. So the first thing that I'm going to do is the vertical shift. In order to have a vertical shift, we're going to add 1. So our vertical shift here is in red, or circled in red, and I'll write it in red as well. So we have g of x is equal to the absolute value of x plus 1. And now if we take a look at the picture, we can see that each output, or each y value, is 1 larger than it was in the picture before. So instead of 0, 0, we have 0, 1, and then we have negative 5, 6 and 5, 6. The next thing we're going to look at is the horizontal shift, and remember that comes from this negative 2 inside the parentheses. So we have h of x is equal to the absolute value of x minus 2 plus 1, which means we shifted it right 2 units. And if we take a look at the picture, we can see that all the inputs are 2 to the right. We went from negative 5 to negative 3, 0 to 2, and 5 to 7. The next thing we're going to look at is the horizontal shrink, and that came about from the 4 out front. So we have j of x is equal to 4 times the absolute value of x minus 2 plus 1. And now, when we take a look at this picture, I had to switch points because negative 3 and 7, if I would have plugged those in, they give me 21. And I didn't want to have to make a graph that big. So I just changed 2 points, and you can see how much the outputs increased, because before we had negative 3, 6, and here we have 0, 9. If we were to, like I said, if we were to plug negative 3 and 7 in, we'd be all the way up at 21. So we shrank this horizontally. And then the last step is to add that negative out front, which is a reflection over the x-axis. So we would have m of x is equal to negative the absolute value of 4 times x minus 2 plus 1. And now when we take a look at the picture, we can see that we reflected it over the x-axis. So it's the same picture as j of x flipped over the x-axis. And that's all for this video on a transformation example.